Hello ladies and gentlemen, my name is Mr. Dotson-Kelly. Today I'm going to teach you guys how to multiply rational functions. Before I give you guys an example, I want to go ahead and give you guys a list of steps for how to multiply rational functions. So step number one, you need to factor every polynomial completely. I have done a video on this previously entitled Simplify Rational Functions Intro. This gives you a list of steps on how to factor. Next, you need to determine your constraints. Similar to what we've done in the past, you want to find out what makes the denominator equal to 0. You are never allowed to divide by 0, and for this reason, we need to find out what input values will result in having a 0 denominator for both of our rational functions. Step number 3, you want to cross-cancel. You want to find all the factors that are the same in both the numerator and the denominator and cross-cancel these. The reason this works out is because these are factors are both in the numerator and the denominator. They would divide by 1 because they represent the same number. Go ahead and pause this video before we move on.
Now that you guys have written down the steps for simplifying and multiplying rational functions, let's go ahead and see an example. Y squared plus 10y plus 25 divided by y squared minus 9. And I'm going to multiply this rational function by a second rational function. That second rational function is y squared plus 3y divided by y plus 5. Step number 1 is to factor completely. You want to factor every single polynomial we see here. I see 1 polynomial, 2 polynomials, 3 polynomials, and a 4th polynomial. And we want to factor each one completely. So I'm going to factor one at a time. The first one I'm going to factor is y squared plus 10y plus 25. So factor y squared plus 10y plus 25. Now this is a classic quadratic trinomial. If you don't know the pattern for perfect squares, that's perfectly fine. You can always ask yourselves the simple question of what multiplies to our constant at the end and adds to our middle term. And you have a list of terms that multiply to 25. So what multiplies to 25? You have 1 times 25 and 5 times 5. Don't forget that you have negatives as well. You can technically do -1 times -25 as well as -5 times -5. But the question is what adds to 10? And that would be 5 plus 5 is equal to 10. So this right here is what multiplies to 10. So my first one, this green one right here, is going to become y plus 5 times y plus 5. I'm going to list it out like that. And again, just to let you guys know where I'm getting it from, I've just done the green one and I got the y plus 5 from here. So this information is all in that green square. I am now going to factor out my yellow. I also want to factor y squared minus 9. I'm going to scoot this up and I'm going to come back to the problems as we continue to factor. So now I'm going to factor y squared minus 9. I want to factor this. I am going to really quickly rewrite this so that I have a y term. But in order to keep this mathematically the same, this would have a 0 coefficient. And if you don't recognize the difference of two perfect squares, you can always analyze it as if it was a trinomial. So what multiplies to -9 but adds to 0? So again, we're going to make a list of factors that multiply to -9. That would be 1 times -9, -1 times 9, and -3 times 3. And we want the sum to equal 0. And the only one that adds to 0 is these two right here. So -3 plus 3 is equal to 0. It's the only one that works. So coming back up here and rewriting this out, this y squared minus 9 will now become y minus 3 times y plus 3. So that is the first rational expression on the left. I now want to factor the one on the right. Fortunately, my denominator is already complete. Y plus 5 is unfactorable. It is a linear factor, so it is unfactorable. But the y squared plus 3y is factorable. This one I can factor using the GCF, the greatest common factor. So what do y squared and 3y have in common? Let's really quickly write this out over here. So what does y squared and 3y have in common? Well, y squared is y times y. 3y is 3 times y. What do these two things have in common? They both have a y in common. So that is what I'm going to factor out. So now I have y times whatever I have left over, and that's going to be y plus 3. Y plus 3. So this was all step 1. Step 1 was factoring. Step 2 is determining what makes our denominators equal to 0. So now I need to know in step 2, let's rewrite this up here, step 1. Step 2 is determining what makes our denominator equal to 0. Ignore what I wrote there, it was an oops. What I want to know is I want to know what y minus 3 times y plus 3 times y plus 5 will give me a 0 in my denominator. So I'm incorporating everything here in my denominators in both sets of denominators. So what will make this 0? This again brings us back to our classic zero product property. So one of these three things, either this, this, or this, 1, 2, or 3, one of these three things will equal 0. So either y minus 3 will equal 0, y plus 3 will equal 0, or y plus 5 will equal 0. And that will give us plus 3 to both sides, y equals 3, subtract 3 from both sides, y equals negative 3, and subtract 5 from both sides, and y equals negative 5. These three numbers will give me a 0 either in this denominator or in this denominator. Now that is something we are not allowed to do because you're not allowed to divide by 0. So what that means is our constraints are y cannot equal 3, negative 3, or negative 5. And that right there is a really important piece of information. Okay. Step number 3 will be to take this fraction, these fractions up here, and do our cross canceling. I'm going to rewrite the fractions I see up above, y plus 5 times y plus 5 divided by y minus 3 times y plus 3 multiplied to y times y plus 3, all divided by y plus 5. And now I'm looking for factors that are identical. Why do I want identical factors? I want identical factors so that they can cross cancel each other. Here I have a y plus 5 in my denominator and I have two y plus 5s in my numerator. I'm going to cancel this one y plus 5 with one of these y plus 5s. Not both, just one. Because what they do is they divide each other to 1. Y plus 5 divided by y plus 5 will equal 1. So now I have 1 in those spots. I also recognize that I have a y plus 3 and a y plus 3 in both my numerator and my denominator as well. Similar to what I did with the y plus 5, I'm going to cross cancel my y plus 3 and my y plus 3, and they are both going to be 1. And now I am left with y plus 5 times 1 times y times 1. So my final answer is going to be y plus 5 y divided by y minus 3. And typically in math, ladies and gentlemen, when you have a single monomial outside, we normally write that in front. So me being a mathematician, I'm slightly uncomfortable with the y at the end, even though it's mathematically sound. So I'm just going to rewrite this so that I have y there times y plus 5, all divided by y minus 3. And don't forget our constraints, which is y cannot equal 3, negative 3, or negative 5. And this right here will be our final answer. So I'm going to quickly zoom out and recap everything I did. What I have here, ladies and gentlemen, to recap is I have a given problem. With that given problem, I took all 4 of these polynomials and I factored them. I factored the green, I factored the yellow, and I factored the pink. And I resulted with this factored rational functions. From this, I needed to determine what makes my denominator equal to 0. And I had the yellow part and the blue part all here. So either the y minus 3, the y plus 3, or the y plus 5 would equal 0, resulting in these constraints where I am not allowed to use these as my input values. You are not allowed to divide by 0, and for that reason, y can be any number on that number line, any number you can think of, except the numbers 3, negative 3, and negative 5. Last but not least, step number 3 is we started to look for what can we cross cancel, and you'll recognize that what I have left is y plus 5 and y, and in my denominator I ended up with a y minus 3. Everything else canceled out. All the other factors canceled out. So as a result, this was my final answer with the constraints added on. So I had my simplified fraction with my constraints. Thank you, ladies and gentlemen, for watching my video. I hope this helps. This was Mr. Dotson-Kelly. Have a good day and stay healthy.